All right, class, welcome to chapter 2. So in this chapter, we will be looking specifically at linear functions and then absolute value functions. But before we get to talk about functions, I definitely want to review with you how to solve linear equations and inequalities in one variable. And then we'll move on to two variables and so on and so on. So here it is, something that hopefully looks familiar to you. So first things first, I would like to take apart this statement. So we will be looking at equations first of all. So for an equation, we definitely need an equal sign, yes. To solve an equation, explained here one more time, means to find the value they replace, or values sometimes maybe even, they're replaced in for the variable makes the equality statement true. So for example, let's jump immediately here, show that x equals to 5 is a solution to this equation right here. So what does it mean that x equals to 5 is a solution? That means that replaced in for the variable, so if we plug in a 5 in place of x, we should be getting the same number on both sides. In other words, we have an equality statement. And sure enough, 15 minus 7 is 8. And that is true. So therefore, x equals to 5 is the solution to this equation. Okay, it is the number that replaced in for the variable makes the equality statement true. So to solve an equation means to find this value. Okay, and then again, sometimes there might be more than one value that makes the equation true. Linear is maybe the questionable word in here. And I've already mentioned that in the last chapters. We talked about linear equations in two variables, and we've graphed them and we obtained lines. So therefore, it was called linear. But really, without graphing or anything, what makes an equation linear simply means that the variable is to the power of 1. So you're not going to see an x squared, you're not going to see an x cubed, you're not even going to see a square root of x or an absolute value of x. Those kind of equations have different names. So really just maybe some number times x, and that's it. So that's the only thing, and of course some other non-variable terms added together to it. Okay, some constant term. So that's how we recognize that we're dealing with a linear equation to the power of 1. Now also, if I continue, these equations are going to have one variable. That's in the next section, we're going to look at equations in two variables. So I know I've scribbled a lot over this equation here. If you look at it, as you see, it has one variable only. And also in this section, we'll talk about inequalities. And for an inequality, you're going to have one of these symbols. One of the inequality symbols. We'll get to this at the end of the section. So here it is. A whole bunch at first of equations in one variable. So if you look at them each single time, even though we might change the name of the variable, in this case to a y, in this case to an n, but they all have one variable in them each. Okay. Now they are all linear, as in you don't see anything else happening to an x but just multiply to a coefficient. So you don't see squares, square roots, absolute values, or anything funny. So these are all linear equations in one variable. How do we get to solve them? Well, here it is. There are some steps that are pertaining to solving specifically linear equations. We are not Once we'll solve quadratic equations, radical equations, there will be other steps. Okay, so number one, let's look at solving the equation that we actually looked at before. We know the answer is going to be 5, but we want to see how do we get there. So the steps of solving a linear equation in one variable would be to simplify each side of the equation as much as possible. As in, if you see parentheses, distribute. So if you see any parentheses, distribute, then combine like terms. So actually things that we practiced on in section review 2R2. Okay. All right, now if I look at this equation here that I'm supposed to solve, there are no parentheses or nothing to distribute. There are no like terms on either side of the equal. So now what I want to do is I would like to do whatever it takes to get all the variable terms on one side of the equal and all the constant terms, so in other words, no variable, on the other side of the equation. How do we do that? Well, I will tell you. So, number one, it's also important to know that to keep an equation balanced, in other words, same solution, whatever we do to one side, we do to the other. Okay, so how do I get these constant terms to one side, variable terms to the other? Well, we're going to do the opposite operation. So as you see here, the 7 was subtracted from 2x. So to undo that subtraction, I'm going to add 7 to both sides of the equal. So I'm going to say this addition and subtraction undo each other. Actually, we call these inverse operations. And so why would we add 7? Because when I look at this equation here and combine what's on the left side, I have a 3x minus 7 plus 7. Well, negative 7 added to positive 7, that's going to equal to a 0. Yes. The only good thing, or the one good thing about adding 0 is that anything added to 0 is just the number itself. So you don't even have to write plus 0 because 3x plus 0 is just 3x. So again, we've started with a simple equation. And as you see now, the variable terms are all on one side. The constant terms are on the other. So the last thing to do to detach from the 3, from the x, is the 3 that it's multiplied to. So between 3 and x, there's a multiplication. So therefore, we're going to undo that with a division. So also multiplication and division. So if there's a multiplication you want to undo, you have to divide. Okay. So how is this helpful? Well, 3 times x divided by 3. 3 divided by 3 is in fact 1. And the good news about it is that 1 times anything is the number itself. So 1 times x is in fact the same thing as just x. So as you see, we got x all by itself, and it tells us that x will have to equal to 5, which is the solution that we tried earlier. Okay. All right, so hopefully you remember all these steps. We're going to follow them one by one. And here it is. We don't want to do too many problems because hopefully you do remember how to solve these problems. So I'm just going to add on a little bit more. I have parentheses, right? So remember, the first step is simplify both sides of the equal by distributing. So the 2 has to be multiplied to 3x, which gives me 6x. 2 times negative 4 is negative 8. All right, now we need to get x by itself. So therefore, I'm going to take the 8 away. And to do so, I'm going to add 8 to both sides. And negative 8 plus 8 is 0. Here's my equal sign. That's going to be a 12 for 4 plus 8. Okay, and then divide both sides by 6 because x is multiplied to 6. So 6 divided by 6 is 1. 1 times x is 1x, also known as just x. So, and of course 12 divided by 6 is 2. Okay, same thing. Distribute in the negative 2. You could try this problem on yourself and come back and check with what we have. So distribute in the negative 2. Then we still have plus 54 and equals to 4. Now, I'm going to show you this. Many students at this point in the problem would add the 22 because you know you have to do the opposite. So what is wrong with what I'm seeing here or what I've done here? What's wrong is that you've dragged this equation down way on the left-hand side and did nothing on the right-hand side. So this equation is not balanced anymore, okay? You've added too much on one side and nothing on the other, so this balance is gonna fall. We don't have the same equation. You do not do these kind of things where you do two things on one side and nothing on the other. Because the negative 22 and the positive 54 are on the same side of the equal, that means this expression on the left side of the equal is not yet simplified. We can combine like terms. So negative 22 plus 54, that should be a positive 32. And so again, we distributed combined like terms. And now we're ready to move things away. So we're going to minus 32. And 4 minus 32, again, please use your calculators. You don't need to do this in your head. I'm just not wasting time pulling out a calculator for this operation. But you definitely can do that. Make sure you get the right answers. This is a calculator-based class, so we are using our calculators to help us get to the answers. Okay. So divide by 14 again as the last step because it was multiplied to x, so that's how we detach it. And negative 28 divided by 14 is negative 2. Okay. So here again, a couple more. You are very welcome again to stop the video, try the problems yourselves, come back and check in with us. I don't know why I say us, it's just me out here. So I'm going to distribute the 4. So I'm going to get 8. 4 times negative 5 is negative 20y. Same thing, distribute the negative 7. And here you have it. Combine like terms. So I have a negative 7 minus 20y equals to negative 7y plus 18. So there I have it this time. I have variable terms on both sides of the equal. It doesn't matter which ones I take away. The point is one of these guys has to move. So you can add the 20y over, or you can add the 7y. Remember, whatever you do to one side, you do to the other. So that's going to be a negative 7 minus 13y, because this is what negative 20y plus 7y equals to. Here's still my equal sign. And negative 7y plus 7y are 0y's. And it so happened that 0 times y is 0. And so it doesn't matter what y is, we're going to get a 0 there. And 0 plus 18 is still 18. So therefore, those terms have canceled each other out, if you want to say. All right. So I have my variable terms on one side. Now I'd like to get the constant terms to the other. And the last thing to do is get rid of the negative 13. Again, it's not adding the 13 because 13 is not subtracted from y. Negative 13 is multiplied to y. So to undo that multiplication, we divide both sides by negative 13. And you are welcome to give me a decimal answer, or you're welcome to just, again, 25 divided by 13 is not going to be an integer. It's almost negative 1.9 something, I'm going to guess. If you put in your calculator, that's fine. Or you can just leave the answer as a fraction. Okay. So here it is, 0.05n distribute plus 0.10n plus 0.70 equals to 3.55. Combine like terms, so that's going to be a 0.15n. And again, you can very well use your calculators for this. I still don't really need a calculator. Subtract 0.70. And 3.55 minus 0.70 is 2.85. And the last thing I'm going to do is divide by 0.15. So again, 1n is going to equal to 19. Again, what I'm showing you is that it doesn't matter whether we deal with integers, decimals, all sorts of numbers. You have your calculators. They're going to help you get to the answers. So put it all in your calculator. What you need to remember, again, is that if you want to undo an addition, you subtract. If you want to undo a subtraction, you add. If you want to undo a multiplication, you divide. Okay. So just to prove a point that it doesn't matter what kind of numbers we're dealing with, we have calculators. Let's zoom into this question here. So what do I see? No parentheses, so nothing to distribute. There are no like terms. So if I look at the left-hand side, I have an x term and one without. Same thing on the right side. So there are no like terms. Great. So I'm going to start by getting all the x's to one side. So I'm going to minus 2/5 x from both sides. Now, combining like terms, where's my calculator? I had 3/4 minus 2/5. I had 3/4 x minus 2/5 x. Well, there it is. Press and enter. 7/20. Done. So you don't need to. You do not need to try and come up with common denominators, do things like that, you have a calculator. That's it. And 2/5 x minus 2/5 x is no x at all. Okay. And finally, I need to get the constant terms over, so I'm going to add 1/3 to both sides. I'll take it over. So I have 7 over 20x. Negative 1/3 plus 1/3 is 0. And 2/3 plus 1/3, by the way, that's 3/3, which equals to 1. You can put in your calculator, right? So the last thing to do is to divide by 7 over 20. Again, there are tricks of making this problem easy, such as multiply by the reciprocal. If you remember, don't worry about a thing. Use your calculator. What is 1 divided by, I would put 7 over 20 in a parentheses. You could have done the same thing for the problem above. I just want to make sure your calculator is not getting confused. So I take the number 1 and divide it by 7/20, right? And when I press enter, fine. Here's the answer, 2 6 over 7, which, by the way, is 20 over 7, which is the same thing as 2 6 over 7. To divide by a fraction means to multiply by its reciprocal. So, same thing. All right, let's keep on solving equations. So, right here it says not all equations will have a solution. So if you see, all of these problems we have done had one answer only. So let me write this down. So linear equations in one variable will have always one solution. Unless we are in one of these situations down here on the bottom. So we have a couple more problems to try. Let's see what happens with these problems. So what else could happen? Well, let's distribute the 60. Again, put in your calculator. So when you distribute these, actually, if you look at this equation, it starts to look funny because what you might notice is that you have the same exact quantities on both sides of the equal. Right? And if you even start by trying to get the x's to one side, 120x minus 120x is 0, and 0 plus 60 is 60. And the same thing happens on the right side. 120x minus 120x is also 0, and 0 plus 60 is 60. And if you look at it, there's no holding the variables back. They're completely gone. However, when you look at the statement that you have, and you can even continue by minusing 60 from both sides and end up with 0 equals to 0, it doesn't really matter. The point is that both these statements are equations that are always true. So what we have is that the variable x can be any real number. It doesn't matter what you're going to substitute in here for x. The left-hand side will always equal to the right-hand side. So you're getting a true statement, okay? So again, remember, to solve an equation means to find the values that replaced in for the variable make the equality statement true. Well, any number plugged in here for x would make the equality statement true. Plug in a 0, you get 60 equals 60. Plug in a 1, you get 180 equals to 180. Plug in whatever, the left-hand side will always equal to the right-hand side. We call this equation an identity. In other words, the right side always is identical to the left side. Now let's see what happens in this situation here. Let's distribute the 3. So 3 times x is 3x. 3 times negative 2 is negative 6. Plus 9 equals negative 12x plus 15x and minus 20. So when you combine like terms on both sides, you see again that you have the same amount of x's on both sides. So when we try to put the variable terms together, so take the 3x away from one side, they're going to be gone from both sides. Okay, so 3x minus 3x is gone. 3x minus 3x is gone. It's 0. X is both times. So you end up with a statement that is never true. No matter what x is, the left-hand side will never equal to the right-hand side. So in this case, we have no solution. So we will get, and this equation here is called a contradiction. So we do get, we call these conditional equations because they work only under the condition that x is 20 over 7, or the n is 19, or the y is negative 25 over 13. So we will get one solution for these equations. And again, the clue later on, as we'll solve several equations, is that it depends on the power of the variable, highest exponent of the variable. So because our variables come to the power of 1, we get one solution. Okay. So we will get one solution unless we're in one of these situations where we get nothing or everything. So you can't have 2 answers, 3 answers, 5 answers. It's always going to be one answer, or in funny situations, you get all real numbers or nothing. Okay, so let's try a couple more. Here it is. Be sure to distribute first. We need to simplify. The left-hand side looks as simple as it would ever be. The right-hand side has some parentheses to take out. 9 times 4 is 36. 9 times 5 is 45. Negative 6 times 3 is negative 18. And negative 6 times negative 10 is positive 60. And now when I combine like terms, 36u minus 18u is 18u. 45 plus 60 is 105. So there you see it again. You have the same amount of your variable on the left side as you have on the right side. So the variables are gone out of the equations. They've crossed out. And negative 51 is never going to equal to 105. So therefore, we'll get no solution in this equation because it's never true. So therefore, the equation above is never true. So and so on and so on. These are all equivalent equations. In other words, they have the same answer. And they're equivalent equations because we've changed both sides of the equal the same way. All right, one more. 0.05 times 12, I believe, is 0.6, but I'll double check with my calculator. Yep. Plus 2x. 5 times 0.41 is 2.05. And 5 times 0.12 again is 0.6. So combining like terms, I get a 2.05x minus 0.6 equals to 2.05x minus 0.6. You really don't need to continue to say this is an identity. Both sides are exactly equal to each other. But fine, if you want, you can minus the 2.05x from both sides, and you end up with something that's always true. So the solution is all real numbers. And again, if you do not like to write all of this, you can just write all real numbers, the symbol for it. So we practiced very much how to solve linear equations in one variable. I know you've done these before in your math classes, but here was a little review, if anything. Okay. So let's solve these linear inequalities this time in one variable. It turns out that we'll do pretty much the same exact things. For an inequality, as you see, we have to have the less than or equal, greater than or equal symbols. So that's what inequalities have. Okay. Now, the way we're going to solve an inequality is really pretty much the same way we solve an equation. We're going to try and get the x by itself. So we're going to add the 7, divide by 3, that's the same equation, or this is an equality, but it's the same exact expressions that we had in our first equation. Okay, and we end up with x is less than 5. Well, it turns out that there are infinitely many numbers that are less than 5. Inequalities will have infinitely many solutions. There are a whole bunch of numbers that would satisfy this inequality. Okay. So we're going to have to rely back to 1.2 when we talked about interval notation. I'm going to help you. We want to write the solution in interval notation. I'm going to help you a little bit. The graph always helps. So as a matter of fact, in the homework, I'm going to tell you to do both graph and write the answer in interval notation. So where are the x's? The x's are to the left of 5. So somewhere on the number line is 5. Remember, the number line stretches from negative infinity to positive infinity. And then there's one more thing to worry about. The actual boundary point is not included. So x cannot, in fact, equal to 5. Okay, it's just strictly less than. So the interval, when we write the interval, we always say what's been shaded, and we always start with smallest possible value, comma, largest possible value. If the end point is included, you put a bracket. If it's not included, you put a parentheses. Okay. All right. We'll practice on this some more. So we'll do a lot more problems. So let's continue to the next one. I want to get the variables to one side, so I'm going to subtract 8u from both sides. So 5 minus 8 is negative 3u is less than or equal to negative 21, because again, 8u minus 8u is 0. And here comes the one and only difference between solving equations and solving inequalities. I do need to divide by this coefficient of u, which is negative 3. Okay. However, whenever we, and I'll write it here on the side, whenever we multiply or divide an inequality, so not an equation, an inequality, by a negative number. So I'm not talking about subtracting something. I'm talking about multiplying or dividing by a negative number. The inequality symbol has to be reversed. And I can quickly show you on the side. For example, I hope that you all agree that 2 is less than 10, yes? Now if I divide both sides by 2, I'm going to get a 1 and a 5, and 1 is still less than 5, no problem, yes? Okay. However, what happens if I divide by a negative 2? I'm going to get a negative 1 compared to negative 5. How is negative 1 compared to a negative 5? Remember, if you are left of another number, you're lesser than that number. So negative 1 is in fact to the right of negative 5 on the number line. And in fact, negative 1 has to be greater than negative 5. So whenever we divide by a negative number, we need to reverse the inequality symbol. Here, let me show you another one that make even more sense. What do you think about negative 3 compared to positive 9? Negative 3 is definitely less than positive 9. Let's divide both sides by a negative number. Well, negative 3 divided by negative 3 is a positive 1. 9 divided by negative 3 is negative 3. How does 1 compare to negative 3? Well, it's greater. It's a positive number. So see, anytime we reverse the inequality, we divide an inequality by a negative number, we have to reverse the inequality symbol. Okay. So keep that in mind. That's the difference between an equation. Maybe we had to reverse the equality symbol too, but the thing is, when I reverse it, it looks exactly the same. So there's no reason to reverse anything. So we are getting negative 3 divided by negative 3 is 1u. Negative 21 divided by negative 3 is positive 7, and you have to reverse the inequality symbol. So here's my number line, and here is my number 7. The values I'm looking for are greater than 7, so to the right of 7, or 7. So 7 is included in my answer. So this is the answer, therefore. Bracket 7 all the way to infinity. Okay. So let's try a few more problems. And same thing. Be careful about the fact that you have to swap the inequality symbol in case you divide by a negative number. But the steps prior or any other steps are the same. So if you have parentheses, distribute the parentheses. Combine like terms if you have any. Get the variable terms to one side. So I'm going to minus 7k. Get the constant terms to the other. So I'm going to get rid of the 2 because it was added. I'm going to minus it. So again, We reverse the inequality symbol when we divide or multiply by a negative number. Now, when we subtract something from both sides. So I'm getting negative 4k is greater than or equal to negative 28. And there it comes. I have to divide both sides by a negative number. Therefore, I am going to reverse the inequality symbol. So, less than or equal to 7 means to the left of 7, including 7. So the solution in interval notation will say anything from negative infinity up to 7 and include the 7. Okay. Here it is. Distribute if you see parentheses. Combine like terms. And you might notice that I have the same amount of x's on both sides. Okay. So I'm going to end up with negative 15 less than negative 35. The x's are gone out of the equation. Great. Inequality. The question is this a true statement or not? Just comparing two numbers. So will negative 15 is either always less than negative 35 or never. So negative 15 is in fact more than negative 35. So that's not true ever. Therefore, there is no solution for this inequality. So I want to show you one more time that don't get scared the fact that you have fractions because you have calculators. So as a matter of fact, you see that we have like terms on the left side. They both have x's to them. So let's use our calculators. What is 3/4 minus 1/3? That's how fast it goes. 5/12. No problems. So I have 5/12 many x's. Oh. Oops, minus 2. Minus 1/2. Okay, no problem. When I get the x's together, they will be gone out of the equation, or the inequality. So I get 0. Because there's 0x and that's just the 0. And is 0 less than or equal to negative 1/2? Nope. So again, this inequality has no solution. Because we end up with a statement that is never true. All right. So last statement here, we're going to come bumping into them in a few sections. Double inequalities. How do we get to solve these? Now, in a double inequality, what you're going to notice is that your variables are going to only show up in the middle. So, the nice thing about double inequality, you have two inequality symbols. However, to get to x, you would do the same steps whether you solve the left inequality or the right inequalities. It's the same steps that will get you to x. So we might as well work with all three sides at the same time. So in other words, to get x by itself, I'd have to add 5. So I'll add 5 to this side and I'll add 5 to this side as well. I'm solving both these inequalities at the same time. So I'm going to get a 7, and I'm going to get a 19. And then I'm going to divide by 3 to get to x. So I'll do that to all sides. Okay. So what happens here is that I'm getting my x's to be bounded on both sides. So 7/3 more than 7/3 is 19/3, so I'm going to the right. However, the x's are in between, so in between 7/3 and 19/3. It doesn't go all the way to infinity or negative infinity. So the interval is bounded on both sides. We're going to go between 7/3 and stop at 19/3. Okay. Here it is, last inequality. To solve it, I'm going to get to the 2x, I have to subtract 5. And again, I don't want to get the x's away. I want to keep the x's in the middle. And what this negative 2x has, it's that it's added to a 5. I just put it in a reverse order, but it's a negative 2x added to a positive 5. Therefore, I minus 5 from all the sides. So I'm going to get a negative 18. Oops, just less than. Negative 5 minus 5 is 0. 0 minus 2x is negative 2x. And then a 12. So be very careful. You are dividing now finally again an inequality by a negative number. Therefore, your inequality symbol has to be reversed. And good thing that we reversed it, because an inequality always has to point to the lesser number. And 9 is definitely more than negative 6 and not backwards. Okay. So if I put these numbers on the number line, negative 6 comes first, 9 is to the right of it, is greater. So, and the x's are less than 9, but more than negative 6. So remember, an inequality always has to start at the smallest possible value, comma, largest possible value, and it does. So the lesser number here is negative 6. All right, so here is your section 2.1.